Hello guys, I'm back. My name is Jefferson Costa. I'm a chemical process engineer with expertise in plant design. And today I will talk to Dawid Hanak, and he a PhD. And it is the first PhD I met in my life, so it's very nice to have so source of knowledge at my front of me. And we'll talk about carbon capture and also the academic and industrial career, something like that. So Dawid, please do a short introduction of you. And guys, always let us know where are you from in order that I can share with Dawid who is watching us.
Sounds great. Thank you, Jefferson. Hi, everyone. I'm Dawid Hanak. I'm a senior lecturer in energy and process engineering at Cranfield University. It's somewhere between Oxford, Cambridge, and London, if you don't know where Cranfield is. So my expertise is actually feasibility assessment and business model development of carbon capture technologies. I'm power engineer and process engineer by training. And I'm happy to discuss those topics today.
Dawid, I have my first question is to my guests. Usually, is how did they get his first chemical process engineering job? But you start your career in academic. So
Yes.
instead of asking that, let me ask you: how was your first job after you finished your graduation, and how did you get it, and how it is? It was. Sorry.
Right. So my first degree was actually in energy and environmental engineering. So I got a first job as a sales consultant for a company that was basically promoting clean energy. So we talk about solar thermal panels for domestic application, heat pumps, all of those, controllers and stuff. So I got familiar with this, and that was my very first job, right? And I got it because I started as an intern with that company during my bachelor's, and straight after I got a job with them. Later, I started, going through my master's in power engineering, and that's how I got onto a PhD at some point.
So you start in the industrial, but as
I
you
started in the
increase it,
industry, yes,
it's
but it
nice.
was in clean energy, so it was somehow related, but it was more business oriented rather than, chemical process engineering.
And why shifting from academic to industry? From
You
industry
mean,
to academia. Sorry.
okay, right. So basically, during my master's, I got an opportunity to travel to the UK, actually to do double masters in process engineering, which was tailored towards carbon capture. So it was carbon capture and transport at Cranfield, actually. And that master degree actually included 6 months research project. And I really enjoyed this project. So I had actually the opportunity to drive how I'm going to develop the project, what I'm going to research. And basically, I really enjoyed working, on design, but from, low technology readiness level perspective. So that's why I kind of decided, let's move a little bit into research. Let's try how it is. I really liked what I was doing, so I decided to do a PhD after that.
And just to let you know, we have people from India, and we always have people
Okay.
from India. But this time, who is as watching us is no one more than Vijay Sarati. So we have very important people watching us today. Vijay Sarati is very
Perfect.
a good friend, and he was with us some weeks before.
Yes. Yes,
And
I'm following him on LinkedIn as well.
yes, if you are a chemical process engineer and you don't know Vijay Sarati, you are not in planet Earth. Okay, so sorry. We have also people from Nepal and Philippines, and it's very
Nice.
nice to have all of you with us. And you now your main activities is in the academia or in the academic, but you are also a process constant. How is it? How do you do you manage both of them, and what is the difference in something like that?
Okay. Right. I think the difference. So the fact that I'm an academic and process consultant comes from the specificity of Cranfield itself.
Mm-hmm.
So Cranfield is more research-oriented university. We work a lot with industry. So we work a lot on, research project consultancies, third-party validation projects. So this kind of stuff. So basically, my work is 60 to 70% interaction with industry and doing actually research. So it's not very difficult to manage both because it's part of my job description, I would say.
Mm-hmm.
And then the academic stuff, it's more, I'm a course director as well. I think we're going to touch on this a little bit later. But that also kind of helps me to, this kind of consultancy engagement helped me to reflect on the course, and I know exactly what to include in the curriculum so that I can develop better process engineers, chemical engineers for the future.
That's very nice because it's not an issue only from Brazil. I have been in touch with people around the world, from Zambia to Australia, and we see a disconnection between the academy and the industry in many cases. But as your department applied to let's say socially applied, you can have a better vision and help better the students, right?
Yeah, we as I said, we work with industry directly, and it's quite common actually for academics to jump from academia to industry, then back to academia, or you've got some sort of programs that allow industry people actually come to academia and stay for 1 year or 2 years and work with us on research development. I mentioned technology readiness levels. So basically, we work across different technology readiness level, not only 3 to 1, which is basically concept development, feasibility, and so on. We also develop up to about 6, 7. So we've got this capability to demonstrate the labs. And some of our facilities, we work, for example, we used to work with BP on a 3-phase flow testing, this kind of research.
Okay, and to go to the subject of this live session, what is carbon capture? Because many people don't know what it is.
Okay, let me share a slide with you.
Okay.
I've got this one prepared. It will be just easier to present. Just put this, and I can share this one.
We have people from Pakistan, and Sahib Hassan is with us. Also, very nice, very important people with us today. Everyone wants to see a PhD talking, right? And see what if it is possible to get the PhD knowledge and apply in real life. That's sometimes. And sorry, because I'm an executor. For sure, I'm an executor. I'm not a researcher. And sometimes we have this kind of preconcepts in our mind when we talk about PhDs. And thanks for accepting my invitation to clarify that.
Right, that's fine. Happy to answer any questions, to be honest. Right, can you see my screen right now? Can you see the presentation? Yes. Right, so basically, carbon capture storage is a concept. It's a technology that aims to remove carbon dioxide from the flue gases or from off gases of industrial plants. So any kind of flue gas that has between, 4% of CO2 from natural gas combined cycle power plants through to cement industry, where we've got 30% CO2, you can put a carbon capture on it. I'm going to talk about some challenges in a minute, but in general, we have two value chains. One is CCS, carbon capture storage, where you've got actually carbon emitter, point source of CO2. Now you capture carbon dioxide, you condition it, so you compress it, remove any liquid, any moisture out of it. And then you can either store it in geological formations. So basically, if you've got a depleted natural gas field, you can store carbon dioxide in there. There are some concepts actually that use carbon dioxide to produce even more oils. That's enhanced oil recovery, where you actually push carbon dioxide, use carbon dioxide to push more oil out of the reservoir. Some other uses, so the other value chain is carbon capture utilization. It's coming up recently. It's not that popular yet because we don't know exactly what to do with the CO2 yet, because it's so much. But there are a range of there is a range of options. Mineral carbonation is quite interesting one. So basically, you produce crystals, so you produce carbonates out of CO2, which you can easily store, or you can have a number of industrial uses. With industrial use of CO2, we have to be very careful because, as we briefly discussed before, of course, you can use CO2 for beverages, for example. But once you open your bottle with Coca-Cola or something, you release CO2 out of the bottle. So basically, you shift the emission point, right? So with this, we have to be sure that we can lock CO2 permanently. You can produce plastics. It's not, again, you may create another issue with this, but it's an option. Or you can produce building materials that to stay lock CO2 for a long period of time, or some sort of chemicals for synthesis, for chemical synthesis later on. So let me just go. Yeah, so this is just a summary of what I just said. I can share the slides with you if you want after this presentation. So the main challenge is, right, we've been using CO2 capture for gas sweetening, for example, for decades right now. But you've got much more, for flue gases, you need much stronger reactions. You need chemical absorption rather than physical absorption or physical polishing. So the cost associated with that plant, with CCS, with carbon capture plant, actually, is about 90%, 70 to 90% of the entire system, of the entire cost of the entire process. And it's at the demonstration phase. It's not mature technology yet. For CCU chain, as I mentioned, we have different uses. I mentioned all of those already. So in terms of different approaches for CO2 capture, my work actually focused mostly on power generation. Hence, this is more tailored towards power generation. So we've got post-combustion capture, which is the easiest way to actually use carbon capture in existing systems. Basically, if there is a space on the existing power plant, like there is enough land or something, we can retrofit the power plant. We can put additional chemical plant next to the power plant and separate CO2 from the flue gases. It's a little bit energy intensive. I will give you some indication in a minute. And there are some challenges with it, like, do we have enough space? Do we have enough steam in the plant to actually regenerate the system, regenerate the solvent, and so on. Pre-combustion is a little bit less mature technology, although we've got gasifiers in industrial maturity. But what's good about pre-combustion is you can use biomass, you can use coal, any kind of solid fuels to produce hydrogen. And then hydrogen, if you basically store CO2 or do something with CO2, hydrogen can be considered as a net zero carbon neutral fuel if you actually do something with CO2. And then you can use it for heat and power, but also you can use it for any other industrial applications. And oxy-combustion is something that has been done in industry at some point for different applications, not for power generation. But the main principle here is actually, instead of combusting fuel in air, you basically combust it in oxygen. There are some challenges, again, with materials, because if you combust in oxygen, your temperature rises rapidly. You've got very high temperature of combustion. So you probably need to recycle part of this CO2 back to control the temperature. So you've got limitations from the material standpoint. So again, challenges. So the main issue with CCS is it's expensive because, okay, you can get up to minus 90% of CO2 emissions compared to reference power plants. If you consider life cycle, it's about 70%. But for the process, you can reduce emissions by 90%, CO2 emissions by 90%, which is extremely high. But you've got the loss of efficiency of about 12 points, up to 12 points for the very mature technology like amine scrubbing, or for new technologies like using solid sorbents, you can have a very lower efficiency penalty of about 7 points. What it actually means is if you had a power plant which operated at nominal efficiency of 40%, if you put carbon capture on it, it will operate with about 33% efficiency. So basically, from advanced coal-fired plant, in this case, you get back to subcritical power plants. So it's not very efficient. So that's the challenge with CCS right now. Yeah, here I've got a couple of examples of the efficiency penalties. So you see amine scrubbing, oxy-combustion up to 12, 11 percentage points. Of course, there's a room for optimization. So further research is being done on these technologies. Calcium looping is something I was researching for my PhD. And you can get to very low efficiency penalties of about 3-5 percentage points. But essentially what you do, you have to attach additional power plants next to your system. So it's, again, very capital intensive. Yeah, and this is just a highlight of what's going on. So let's say you've got the power boiler, and you produce steam. So if you want to run carbon capture plant, first of all, you have very high flue gas flow rate of up to 700 cubic meter per second. So it implies that your absorbers will be enormously big. Probably you would need to have about 3-6 absorbers to capture this. So again, footprint of the plant will be higher, and you have higher capital cost. Energy requirement, you've got steam extraction. So basically you lose energy from what you would have usually generated. So say in coal-fired plants with amine scrubbing, you look at about 20 to 30% loss in power generation capability. So this is something that needs to be addressed. Of course, compression also, it costs energy. And yeah, I've got a couple of slides on economics. I don't know if this is interesting. These are a little bit outdated, but look nice. So if you want me to continue, I'm happy to continue just briefly on economics.
The time is yours, Dawid. The time is yours. You are the guest. You are the ruler here. Do what you want.
Right. So yeah. So basically, it's expensive. CCS. You see, it requires a lot of energy. And if you compare CCS applications, so you have natural gas processing, biomass to ethanol, fertilizer production. So this is pretty cheap, right? About $20-30 per ton of CO2. Of course, it's a little bit outdated data, but it's still more or less accurate. If you consider application of CCS to existing systems, existing power plants, and industrial plants, you can see that the cost per ton will be very, very high. So it's much more than, for example, CO2 allowance price in Europe, which is roughly about $20, let's say, per ton. So basically, still there are no incentives for the industry to do CCS unless we can reduce the price. Yeah, this is just a comparison of different technologies. So CCS, again, still expensive. These 2 or 3 guys have dramatically dropped down recently, but those figures don't account for energy storage costs. So basically, you have to consider cost of energy storage here as well. Yeah, but the positive thing is, if we start deploying technologies, we will start learning about them. We will be able to actually do a cheaper plants. And this is what actually industry started to see. We had a couple of demonstrations for CCS that I can show you in a minute. So basically, yeah, you see, 2005, that was supposed to happen. We should have first demonstration, but it didn't happen until I think it was 2016 or 2017 when we had boundary dam demonstration. So you see this shifted more or less. But this estimation showed that we should have the first of a kind power plant retrofitted with carbon capture of about $100+ per ton. And if you look at the boundary dam, they actually had more or less $130 per megawatt hour, which translated to about $90 to $100 per ton of CO2 captured. But what they said is if they were supposed to do next plant, it will be, again, 30% cheaper. So it more or less follows this learning curve. The same applies for Shell Quest. So basically this was, so boundary dam was solid fuel power plant, lignite fired power plant of about, I think, 120 megawatts. I don't remember off the top of my head right now. Shell Quest was hydrogen oil refining plant. They use solvent scrubbing, which is quite common technology in the industry, and they got about less than 80 per ton. And again, they can do additional reductions on the next similar unit. And Petranova is the most recent demonstration on coal-fired plants. Again, solvent scrubbing and similar performance as boundary dam. So basically, for now, if you look at the industry, they actually consider the off-the-shelf technologies because that's what they do. And this is usually solvent scrubbing for carbon capture. Although it's expensive, it seems like sometimes you just have to deploy it to meet the environmental regulations, right? Yeah. So I was talking. It may have come across a little bit negative because CCS is expensive. It takes a lot of space. You need to modify your plants. But actually, if you look at the bigger picture, if you consider the decarbonization scenarios, if we don't do CCS, the cost of decarbonization will be 140% higher, mostly because there is a limited scale that we can implement renewables like wind, solar. They are intermittent, and CCS needs to be in the mix in one way or another. And yeah, I think, this is just some of the process flow diagrams that I did. I'm going to talk about this in a minute. Okay. So this may relate to some other work that I did. So I'll just stop. Yeah, fair enough. Yeah.
And okay, and let me ask you. I have some question pre-filled question here to help me. And net zero emission is the same as carbon capture?
It could be. It doesn't necessarily mean it's zero. It doesn't mean that carbon capture is net zero emission. So as I mentioned, carbon capture, if you retrofit it on power plant or industrial plant, it can capture up to 90% of CO2 from the flue gases, for example. It's because of the chemical equilibrium. You cannot go above. Well, you can go above, but it will be extremely expensive. So there is the exponential cost associated with it. So 90% emission reduction is the most optimal from the economic point of view. Net zero means that if you look at the process, it doesn't emit any CO2, right? So basically, if you do a CCS on biomass combustion systems, like BECCS, we call it BECCS, bioenergy with carbon capture, biomass is slightly it depends on the source, right? It can be considered carbon neutral, or it has very little environmental impact. So if you capture carbon dioxide from biomass combustion, you can get into carbon negative emissions. So basically, if you look at the bigger picture, you can take away CO2 from the atmosphere. Of course, there are different opinions about this, and depending on whether the biomass is sourced locally. Because if you take biomass, for example, from Australia and you burn it in UK, you have to consider all of those transportation emissions, right? Mm-hmm. So net zero technologies is something like if you use hydrogen produced from renewables, it may not have any environmental impact. Not CO2. It will not have any CO2 emissions. So net zero is different from carbon capture, I would say. Yeah, that was the question. Yeah, it is different.
Okay.
Yeah.
And we are here to share our knowledge with the chemical process engineers, and most of them are graduate ones and fresh engineers. And of course that they are very worried about jobs and how to get inside the job market. So what is the roles of the chemical process engineer in this field, and what the fresher and the graduate should know to get inside this market?
Right. So I get this question quite a lot from my students. So basically, if you're interested in carbon capture, right? So this is very, I don't want to say new field because it's been here for more than 20 years, but it's still developing. It's still lots of research. So main kind of positions would be in kind of research engineering, like a research engineer on a project, process design development consultants, because companies, they usually understand what carbon capture is, but they don't know how they can deploy it. So they reach out to consultants. They even they even have their own R&D industry, the R&D teams that work on this kind of projects. So I would say research engineer, process design engineer, and of course project engineers, right? So project engineers is quite popular position that the students from my course actually end up with at some point.
And there is a consolidated market with companies that is specialized on this subject, or it's more Shell has a department and he's started to research about that. How is your point of view about this?
I would say it's both, right? So if you're following LinkedIn, you see that most of the biggest oil and gas companies, they start talking about sustainability and environmental issues, like BP committed to net zero recently. So basically, those large organizations, they look for people with skills in sustainability and environmental assessments, for example. From my experience and looking at where my students and my colleagues actually go, I could say that, say for example, my co-supervisor from my PhD, he left academia a couple of years ago, and now he's working with Petrofac, and his actually title is CCS consultant, senior CCS consultant. So they develop their own departments, right? Mm-hmm. And in terms of companies, I did a little research recently, and if you're interested, you can have a look at the websites actually of Petrofac, Technip, BP, BOC. Drugs, of course, it's one of the biggest CCS player in the UK. And then you've got, so that's the technical bit, right? So you've got chemical and process engineering. If you're more interested in risk, reliability, management, then Zurich also, they look for these sustainability technologies. But it's a big players, right? Mm-hmm. So what I saw recently, especially last year and this year, you've got lots of SMEs, lots of startups in the sustainability space. especially in the US, in the UK. I haven't seen anything in in Asia yet. But basically, you've got those companies that kind of, it's a spin-off out of universities like carbon engineering. So they do direct air capture with fuels production, for example, Climeworks, Global Thermostat. But also you've got companies that are specifically kind of dedicated to CCS. And you, for example, in UK, you have sea capture and clean carbon solution or carbon clean solutions. So basically they develop the technology. So they are technology developer for scrubbers, so chemical scrubbing, for example. So it really depends on your career aspirations, I would say. If you want to work for a large organization, there are opportunities within specific departments. If you're looking to work in more dynamic environment, like startup environment, it's always fascinating. Then, of course, there are also opportunities. And then, of course, research, right? You can do a PhD. You can be a research associate with universities. Yeah, I would say so.
You had a process flow diagram to show to us, and let me ask you. You use process simulation software to do that, and which one, or which part you need to do hand calculation and something like that? Could you share with us?
Yeah, sure. I can show you the process flow diagram actually, if you want to. The one that I had. Just open that one up. It's quite interesting. I mean, most of my work, I use Aspen Plus to do my calculations. Of course, it has its limitations. So, for example, all of those heat exchangers, compressors in this process. So this process, actually, let me say, it's a calcination process where you have calcium oxide, you heat it up, you have calcium carbonate, you heat it up, you produce calcium oxide and carbon dioxide, right? So this is one of the consultancy projects that we did with Origin Power. So what they wanted to do is, in conventional calciners, you have air combustion. So you put some fuel in the calciner, and basically you produce flue gas with about 30 to 40% CO2 in it. What they wanted to do is to use a heat from solid oxide fuel cell to actually calcine the material. So after the anode, for example, you've got unburned fuel. So you burn a little bit of that fuel in the calciner to provide this heat for calcination. And then they wanted to have like indirect heat transfer from the vitiated air. So the air that goes out to the cathode. So it was pretty simple to actually model the calciner, model all of those conventional steam cycles, all of this. But the solid oxide fuel cell is something that's a little bit tricky because you have to get into electrochemistry to calculate it right. And that is something I developed a code for in Fortran and in Excel, and then integrated that within Aspen Plus environment. So basically, yeah. So in my work in general, as I mentioned, I use Aspen Plus, integrated with Excel or Fortran coding. Why it's not? Sorry, it's somehow got stuck. Right. Yeah. Yeah. So basically that. I also do some work in Aspen HYSYS, but it's fairly similar to Aspen Plus, depending on what the client actually needs. Sometimes we send the files to the client, or maybe they have already existing systems, so they send us files. So that's for process and chemical modeling. I used to do some power modeling in Aspen Plus, although it's tricky, but I much prefer to use gate cycle or thermoflex for steam cycle modeling, for example. And then you have also engineering equation solver for any kind of calculations, I would say.
Okay, and It is very important to the student or the professional know what he's doing, right? Because it's much more, in my point of view, of course. It seems to be harder than doing a distillation because you have chemistry involved and
Hmm.
sometimes it's not so clear.
Yeah, yeah, it's a little bit. If you look at the process perspective, you need to understand the unit operations. You need to know more or less well, you need to know what the unit operation is doing, how to model it, but also how to validate it, because that's important. We shouldn't just assume something and just go with it. You need to be certain, especially when you provide like a third-party validation for companies. You need to have approach to validate your models, um, say using experimental data or something.
And Dawid, I did a webinar last few minutes later before our meeting, and what I said there what the chemical process engineer must know about plant design, and I said that any project starts with a problem. We need to solve a
Mhm.
problem, and that's why we start a project. What is the problem that must be solved when I'm considering to start a carbon capture project?
Right. Okay. It's a big question, I would say. But as I said earlier, the most difficult aspect of doing carbon capture is it takes a lot of energy and it's expensive. So if we consider options to reduce size of the equipment, process intensification, for example, if we consider different new approaches to carbon capture, new solvents, new materials. Yeah, so basically the main challenges that we are facing and trying to solve is how you get the energy requirement, how you get capital costs down, and how you convince the industry to actually get interested.
Mm, nice. And okay, my friend, thanks a lot for being with me here. And
Right.
let's proceed to the end of this presentation.
All
And
right.
uh, let me know why someone should get a PhD. Why
Right.
and
That's
when?
why PhD. Right. I haven't worked in industry like in research industry, There are some research positions in industry as well. Uh, but I believe someone should do a PhD if you're hungry for knowledge, right? If you want to do a research, this can actually help you to dedicate 100% of your time to research one particular topic and become an expert in it. And at the same time, you may solve some specific challenges. So you may develop a technology, you may develop new methodologies, new techniques, something. Of course, you can do it in industry as well, but I'm not quite sure about the timelines in industry. Industry tends to work within shorter timelines. For example, when we have a project with industry, it usually takes about 12 to 18 months. When you have research projects, it takes about 36 months or so because you've got this additional time to actually think about the challenges, to actually develop new approaches, because it's not so easy just to come up with something new, right? You have to have this time. You have to have this time for thinking, brainstorming, and testing. So PhD is it takes a lot of energy. I want to say it's not easy, but it's definitely worth it if you're interested in pursuing not only academic career but in general research career.
Yeah, I have a question from a student of mine, Akshay Patil, and what is your thoughts about gasification process and
Mhm.
its scope in the reducing carbon emission? Do you have any opinion about that?
Yeah, actually, at the moment, I'm working on one of the gasification technologies right now for hydrogen production. Gasification is an interesting process. especially if you can use low quality fuels to produce hydrogen. Say if you can gasify waste, if you can gasify plastic or pyrolyze plastic, that's also quite an interesting topic. The main challenge is it tends to be quite complex chemical plant at the end of the day, because you've got the gasifier itself, but you also have to consider any like hydrogen sulfide emissions. So you have additional scrubber in there, chlorine, any this kind of bad stuff, you have to take it out. So from the production perspective, yield perspective, it's quite interesting because you can produce hydrogen or syngas and then do some interesting stuff with it. From the economic point of view, it might be a little bit expensive if you consider the full cost of the system. Mm-hmm. But definitely, gasification has been with us for decades right now, in one way or another.
Okay. I get in touch with the gasification subject these days in the last weeks about a consultancy in this area. Mm-hmm. And I was not aware about that, get the polymers and gasify that and have liquid hydrocarbons. Mm-hmm. That was very interesting, and I'm getting familiar with that. Now I know another source of information very useful to me.
Happy to help.
And let us know a little bit about your advanced process engineering program and the activities that you do, if you have a YouTube channel or not, and what you do in the internet also to help freshers and graduates engineers.
Sure. As I mentioned, I'm a course director for Advanced Process Engineering course at Cranfield. I took over this course 2 years ago when it was called Process Systems Engineering. So that course the process system engineering was tailored towards oil and gas industry, towards, process instrumentation, measurements, all of these aspects of process engineering. But talking to industry, I felt it's not something that they're looking for. So they weren't looking for graduate with this specific profile. It was interesting that all the UK universities actually tailored their courses towards this one. So I decided to shift the direction to use my expertise and actually change it into more like sustainability oriented. So advanced process engineering, that was the first change. You can say it was more to break from the traditional oil and gas and go into more clean, sustainable direction. So I like to do practical stuff. I don't like, to spend 8 hours talking about carbon capture. I like my students to actually go read something and then do some modeling, do some design, and then we can brainstorm ideas to improve systems, for example. So the course is actually designed in a way that it gives you practical skills, not only in design, not only in optimization and these technical aspects, but I'm a little bit hard on my students and ask them to do presentations and to think about what they want to do after their course. So after they finish, where do you want to go? What career do you want? Do you know the companies you want to go for? And do you know how to approach them? So it's more like technical mentoring, I would say, or career mentoring that goes with the course as well. And yeah, I mean, it's I would like to take this course myself when I would like to have opportunity to do this kind of stuff. So that's one thing, actually. Beyond this, you may know that together with my wife Magda, we launched Motivated Academic. It's a platform, essentially online platform that supports master and PhD students, but also researchers or process engineers, or in general, anyone interested in motivation, well-being. And what we do is we actually share our experience in research. We share experience in a little bit of research on business, project management, task management, all of this stuff. Because we thought that it's quite important. Okay, we know how to do it, but we have to give it back as well. We have to help others. So we have website, motivatedacademic.com. We run some webinars in our private Facebook group, which I can send you a link to as well. And hopefully in a couple of weeks or months, we're going to have some ebooks as well to actually present about, I don't know, writing papers, writing project plans, and doing some research.
You said that in your process program you give orientation to or guidance for your students, and let me ask you, you have a coach certificate background or something like that, and how important is the soft skills for you? Because I have seen that chemical engineers are very worried about technical skills, but they forget about marketing, forget about business, they forget about themselves, how good we must be inside to get anything. So what's your thoughts?
That's what I like about academia. Some people complain about it, but I actually like it because I have to do a marketing. I have to do, this stuff. So I did an MBA recently, just to learn about business, about coaching and leadership. And I feel it's very important. You need to know how to help people. You need to know how to set, say, career development plan. And that's not only for master students, but I mean, that's something I'll be doing with master students anyway, but also with my PhD students and postdocs. So basically, as academics, in general, as leaders, we should help others to grow with us rather than treat them as something that they shouldn't be working for us. They should be working with us, right? So we have to develop them to help them grow as engineers, as leaders for the future. So yeah, definitely soft skills are important, and sometimes we forget about them because we've got these technical skills. We can learn this. It's easy, well, relatively, but we tend to forget. For example, when I was doing my master's, I wouldn't do a presentation. I was so scared to do a presentation, but at some point I realized, well, it's uncomfortable. It's beyond my comfort zone, but if I start practicing, if I start doing this, I'll be familiar with it. I will just get through it. So it's not that difficult. It's just a matter of practice again. And it's important. It's important for industry. It's important for academia.
And about the inner self, I follow some material related to Tony Robbins and also Bobby Proctor, something like that. And when I started sharing my experience in the internet, in fact, I was inspired by those ones. And as I told you in the off, I'm not a speaker. I'm not a teacher. I am someone that don't is shy enough to worry what people will think about me. What kind of support or tips would you give to people that are listening to us about how to strong a better inner self or to get more confident or something like that once you work or one of your tasks is being a guide or a mentor to students?
Right. So there are two things actually. One is what I noticed. People in general don't like uncertain things. So if, say, even in modeling, you need sometimes you need to know exactly what parameter do I use, what value do I use. But sometimes we just don't know. Sometimes we have to determine this. So being confident to make assumptions and to validate those assumptions is important. So that's the first thing, like, be happy working with uncertainty, because world is uncertain and no one will give you answer in industry. You need to find the answer yourself. Another kind of message I would like to kind of share is it is good to have a passion, I would say. It's good to have something that inspires you in your work. So if you can find a specific area that's something that you're very passionate about, and follow this to develop your career, you'll be much happier, I would say, and you enjoy your work more.
Dawid, thanks a lot for your presence and thanks a lot for accepting my invitation at the first time. We're going to finish this live session and please, thanks a lot. It was very nice and we add another perspective in the live sessions here in Process Boosters interview and it was very nice. And please, if you have any kind of last message or tips for the audience, feel free to do that.
Well, I just wanted to say if you want to talk more about carbon capture or research or in general about motivation well-being, you can link with me on LinkedIn or just get in touch with me. Jeferson will probably give you my contact details. Yeah, I'm open person, so if there's anything I can help with, just get in touch. And Jeferson, thank you for inviting me. It's been a pleasure. Yeah, I mean, it's been my very first live interview. So it's been a fantastic experience.
Was it a surprise? Was it a surprise?
It was a surprise, yes, but a pleasant one.
Okay, my friend. Nice to have you in, and we'll see you soon in LinkedIn or in other social media. Or I hope is it close to you? Do you live close to London?
Yeah, it's like 40 minutes train drive. So if you're any time in the UK, let me know.
I will let you know. I'll let you know.
Yeah.
So, bye-bye.
Okay. Thank you. Thank you, everyone.